Hey, what's up you guys? Today I'd like to show you how to find the inverse of a function. So there's one thing that we have to make sure before we actually start calculating the inverse of a function. That function has to be one-to-one. Excuse me, I'd like to know what a one-to-one function is. So in one-to-one functions, for each x in their domain, there's a y that obviously corresponds to that x, right? But in one-to-one functions, we have to make sure that no two x's or more share the same y. Examples of functions that are one-to-one. So x cubed is a function that is one-to-one. There's a test called the horizontal line test that helps you know whether or not a function is one-to-one. So if we draw a horizontal line in this function, it just crosses the function at one point. If a horizontal line crosses the function at just one point, it means that it's one-to-one. So as we can see here, if we draw a horizontal line, it just crosses the function right here. And same if we draw like whenever in its range, it's always going to cross just once. Now, an example of a function that is not one-to-one is the sine function. So, for example, well, the sine function is like this. Now, if we were to apply the horizontal line test to the sine function, we would see that, for example, here, it would cross it twice. So right here and right here. And same, for example, like here. It would cross it here and here. So after we make sure that our function is one-to-one, there's just two simple steps that we have to follow in order to calculate the inverse of that function. Step 1. Interchange the variables. So for the example, I'm going to use the function y equals 2x plus 3. So as I already told you, so the first step is interchange the x and y's. So for this example, so this is going to turn into an x and this is going to turn into a y. So x is equal to 2 times y plus 3. Step 2. Solve for y, or at least try. So I can't tell you that 100% of the times you're going to be able to actually solve for y, but you can at least try. So in this example, I'm going to solve for y. So I'm going to take this 3 and take it as a negative in here. So x minus 3 is equal to 2 times y. Y is equal to x divided by 2 minus 3 divided by 2. So let's sketch the function. So I know that this function has a slope of 2, so it's going to be steeper than the actual function of y equals x, and it's going to cross the y-axis at 3. So assuming this is around 3, we're just going to graph it something like this. And now let's graph this function. So I know that it's going to have a slope of 1/2, so it's going to be less steep than the function y equals x. It's going to cross the y-axis at -3/2. So I'm just assuming that -3/2 is 1.5, so it's going to go somewhere around here, and it's not going to be as steep as y equals x, so it's going to look something like this. There's something very particular about the inverse of a function, and is the fact that it looks like you're taking your normal function and you're reflecting it with respect to the function y equals x. So as we can see here in blue, this is going to be our function y equals x. So this, which is the inverse of the function, is going to look like the reflection of the actual function, taking this as the mirror. The graph of x squared is a parabola, and its vertex is just the center of the plane. So it's going to look something like this, but now we have a problem, and is the fact that a parabola is not a one-to-one function. As we can see, if we were to trace a horizontal line here, it would touch the parabola at 2 different points. Well, that's not good. So what we can do is restrict the function so it becomes a one-to-one function. Now we can say that this function is going to exist as long as x is positive. So if we're making x positive, we have to erase this part of our parabola. Now this is a one-to-one function. If we were to trace this horizontal line here, it would just touch the function at just one point, telling us that now is a one-to-one function. Now let's start finding the inverse of the function. Our first step says interchange x and y. So x is going to be equal to y squared. Now we can say that y is equal to plus or minus the square root of x. However, we said that x had to be positive, so we can't take both of the signs here, so we just take the positive sign here. And that's the function that is going to be the inverse of this part of the function. Now, if we were to sketch the square root of x, we would get something like this. Let's see if our inverse function is equal to the mirror image of our actual function about the y equals x function. Now we can see that if we take this parabola and we reflect it about this axis, we're going to have something that looks like this, which is our inverse function. Now our last example is y is equal to a to the power of x. So the sketch of the function a equals x is the exponential function, which looks like this. So again, our first step is interchange x and y. So x is equal to a to the power of y. Now let's solve for y. So we can say that y is equal to log base a of x. And we know that that function looks like this. Now let's see if this function is actually the mirror image of this one with respect to this axis. So it is clear that the inverse function is actually the mirror image of the actual function with respect to these axes. That was it for this video. I really hope you enjoyed it, and if you did, please give it a big thumbs up and don't forget to subscribe. And I'll see you in my next video. Bye!
Beautiful.